Alright, in this video we want to look at solving some equations that contain logarithms. Really shouldn't be too bad, just for the most part you're going to be rewriting these guys as exponentials. So let's see. Here I've got log base 3 of x equals 4, and if I just fly the plane like we've talked about, that means 3 is the base, 4 is the power, and that's going to equal x. So we just rewrite that. 3 raised to the 4th equals the expression inside, so 3 to the 4th equals x. Please understand this is not 3 times 4, it's 3 raised to the 4th. And we can look at our list of powers and see that 3 to the 4th is 81. So that means that x equals 81. And that's it. And you're done. Doesn't take any time at all. Over here, we have x as the base, so that means we need to rewrite this as an exponential. So that means x, your base, to 1/2 the power equals 49. So x to the 1/2 equals 49. Now, we saw previously that we just need to get rid of that power, and the way we get rid of the power is by using the reciprocal. So the reciprocal of 1/2 is 2. So really, you're just squaring both sides of the equation so that you can find out what x is. So here x is equal to 49 squared. You can take that off to the side. You're going to find out that this is equal to 2,401. And that's it. Very quickly, we get the answer just by flying the plane and rewriting this as an exponential. Let's look at two more. So down here at the bottom we have log base 5 of 3x plus 1 equals 2. X is contained inside of that logarithm, so we want to rewrite this so it's not. And we can again fly the plane. So 5 your base raised to 2 is going to equal 3x plus 1. So 5 squared equals 3x plus 1. So we rewrite it from a logarithmic equation to something that's kind of exponential. But you see here, x is not inside the log anymore. X is just out and about like normal. 5 squared is not 10. 5 squared is 25. So 25 is equal to 3x plus 1. And you solve this linear equation just like you've always done. We subtract 1 on both sides. 24 is equal to 3x. Finish by dividing both sides of the equation by 3. And x equals 8. It's pretty simple to plug this back in to check. 3 times 8 plus 1 is 25. And log base 5 of 25 is 2. Now over here, x is already by itself. So we can use properties of logarithms to work this out. We can also turn this into something exponential. That might be easier for you. So let's see. 49 to x, which is the power, is going to equal the expression inside. So that becomes this equation. 49 to the x equals 1/7. And when you have something like this, you want to identify the common base between these guys. So the common base is 7, so I can rewrite 49 to be 7 squared. Don't forget that there's still a power of x there. And we can rewrite 1/7 as 7 to the negative first. Remember how that negative power corresponds to having things in the denominator? Alright, so here we have the power to a power. So that's 7 to the 2x equals 7 to the negative first. Since these bases are the same, or this is one of those key things that we saw with exponential equations, when you have the same base, that means the powers must be the same, so 2x equals -1. And then we finish solving this for x by dividing both sides by 2. And x equals -1/2. So in all the equations that we had on this page in this video, it was all about rewriting to be in an exponential form. Sometimes it gave you something that was linear. Other times it was just evaluate 3 to the 4th. Sometimes you had to solve for x by messing with the powers. But we rewrite it so that x is in a more familiar position. The only time things get a little bit weird is when we go from x being by itself to putting it in the power. But that's just so that we can more easily work with the equation. Most of the time working with exponentials will be easier than working with a logarithm.